Hello. Today we're going to be solving quadratic inequalities. So there are different types of quadratic inequalities and they are solved different ways. So the first one is just a graph of an inequality. So you'll know it's this one when you see the y is less than or greater than or even the equal to in there. So you're going to go ahead and find your vertex. I'm going to do this by using completing the square just to show it one more time. So we get y is less than, we're going to factor out the 2. So we get x squared minus 4x plus blank. We leave the plus 6 alone, and then we have minus blank. And on the minus blank, we put our a value. When we do b divided by 2, and we square that, we get a 4. So we get y is less than 2 times x minus 2 squared minus 2. So our vertex here is right 2 down 2. We put our point. Our stretch is 2, so I go over 1, up 2. So I'm using my 1, 3, and 5 pattern, so I go over 1 and up 6. Therefore, my y-intercept is 0, 6. Graphically, it works out, but it also works out because of the c value in standard form. So now, normally you would go ahead and you would plot your line here, but this one here, since it's just less than, it is going to end up being a dotted line. If it had the or equal to, it would then be a solid line. Okay, so we have now the shape of our parabola. We also want to figure out which section is shaded, either inside the parabola or outside of the parabola. So we're going to go ahead and test a point. I'm going to go ahead and test 0, 0 because it doesn't go through there. My graph of my parabola doesn't go through there. I'm going to test this in standard form because to me that seems a little bit nicer, but you can honestly test it in any form. We get 0 is less than 6. This is a true statement, which means 0, 0 must be in the shaded region. And so our graph should look like this. So now we're going to solve a different type of inequality here. So first, we're going to take a look at this graph. We can look at this graph and we can write this in vertex form. Our vertex is at 3, negative 2. So our equation should be y equals, it would be x minus 3 squared and then minus 2. For our a value, we go over 1 and we figure out how far we go up, so that is 2. For standard form, we would go ahead and distribute that square and then distribute the 2 out in front and combine everything. So we would get y equals 2x squared minus 12x plus 16. So we could write our equation either in standard form or in vertex form. We are looking for where the y values are greater than 0. So if we're looking at y values greater than 0, on our y-axis, that would be everything up here, okay? So looking at our equation here, all of our y values are greater than 0 on 2 different parts of my parabola here. Everything to the left of 2 and everything to the right of 4. We're going to go ahead and write this in interval notation. So we want all of our values left of negative 2. So that's going to be all the way left on our graph up to 2. And then it's going to then be greater than 0 again, starting when x is 4 and to the right. So we are looking for where our graph, where our y values are greater than 0, but then we're talking about them with our x values. Notice again, these are our x values describing our y values there. What we have just done is we have found where 2x squared minus 12x plus 16, we have found where this is greater than 0. In other words, we have solved for where f of x is greater than 0, where our y values are greater than 0. Now let's compare this to the next one. We are looking for our y values that are less than 0. So on our graph, all of our y values are less than 0 if your y values are the bottom half here. So looking at this, the only part on our graph that has that is everything on this bottom part of the parabola, everything in between 2 and 4. So we are answering the where question with our x values. So it's saying find the x values where your y values are less than 0. So we want everything in between 2 and 4. We're answering in interval notation here. So what we have done is we have just found where 2x squared minus 12x plus 16, we have found these values that are less than 0. In other words, we've also solved where f of x is less than 0, because that's asking for our y values less than 0. So we're going to start asking this question, but we're going to start asking this question using this type of notation instead. So let's go ahead and take a look at this graph. Here we have our graph of y equals negative x squared minus 2x. We are looking for the y values greater than or equal to 0. So what we are being asked to solve is where our y values, are greater than or equal to 0. So what we are looking for on this one is anything that's on this top half of this graph. So anything up here would represent where our y values are greater than or equal to 0. So we can see that it's this portion up here. And since it says or equal to, we want to include the -2 and the 0. So it's everywhere in between -2 and 0. And we use brackets for this one. For this next one, we're looking for where our graph has y values that are less than 0. So in the future, I'll just give you this equation here saying, take this function and tell me where the y values are less than 0. So we're looking for the parts that are on this bottom half of the graph. So what I'm going to do here is I'm going to identify the chunks. There are two separate pieces here where your y values are less than 0. So we need to write these in interval notation. So we need actually two chunks of our graph here. Notice this just says less than 0. So these ones would have an open circle when it equals 0 because we don't want to include the zeros. So left to right, left of our graph is negative infinity. It goes until x is -2, and then all of a sudden it starts again when x is 0, and now we're going to the right for forever. So it's negative infinity, -2, in union with 0 to infinity, all with parentheses. So take a look at number 3, and before you hear the explanation, go ahead and pause the video and see if you can actually identify these two inequalities based off of the graph. So this first one here is asking for our y values less than 0. And so we're looking for the chunk down here below the x-axis. So it's everything in between -1 and 3. And we do not want to include -1 or 3 because it equals 0 at that spot. This is looking for y values that are going to be greater than or equal to 0. So there are two different chunks here where our y values are above the x-axis. This one wants to include the x values. So it's going to be negative infinity, -1 with a bracket, in union 3 to positive infinity. So we're going to go ahead and do one more of these where we actually don't have this graph given to us. So we're going to solve this by graphing, and we are able to use our calculator. So go ahead and take out your calculator, type this into y equals, and find all of these things, the vertex, the x-intercepts, and then we'll talk about the solution together. Okay, so here we have our graph. We've graphed it and identified our vertex and our x-intercepts. We're going to go ahead and solve the inequality now together. We want to know where this is less than or equal to 0. So we are looking for our y values that are below the x-axis. And so we're looking for where on our graph supports that, or where do we see our parabola down there. So it's these two chunks here. So we're starting at the left for forever up until -1. This one says or equal to, so we use our brackets. And then it starts again at 2.6 repeating or 8/3, and then to the right for forever. Those are the x values that have y values that are less than or equal to 0. So that's how you can solve these graphically.